Walls. Framing, sheathing, moisture and air barriers, windows, doors, flashing, exterior finishes, insulation. What is wall? The walls of a building serve several important functions. They define the spaces within the building to provide privacy and zoning, and they enclose the building itself, keeping the weather out and the heat or cold in. Walls provide the vertical structure that supports the upper floors and roof of the building, and the lateral enclose the mechanical systems, electrical wiring, plumbing, and heating. To incorporate all of this within a 4-inch or 6-inch deep wood frame panel is quite an achievement, and numerous decisions need to be made in the course of designing a wall system for a wood frame building. Designing a wall system. Once the stud size and spacing and the framing system have been selected, it is time to consider how to brace the building to resist the force of wind, earthquake, and eccentric loading. Will diagonal bracing be adequate, or should the building be braced with structural sheathing? This question is best answered in the context of the design of the building as a whole, considering the other materials that complete the wall system. How is the wall to be insulated? Where are the openings in the wall for doors and windows? Will there be an air infiltration barrier? What material will be used for the exterior finish? The details relating to these issues are addressed in this chapter, along with some suggestions for the appropriate use. How these details are assembled into a complete wall system depends on local climate, codes, tradition, and the talent of the designer. Framing. In this chapter, all 2x4 walls are shown with studs at 16 inches on center. All 2x6 walls are shown with studs at 24 inches on center. Unlabeled wall may be either 2x4 or 2x6. Take a look at this detailed illustration. Rake wall. A wall that extends to sloped roof or ceiling is called a rake wall and may be built one of two ways. Platform framing is commonly the method of choice when a horizontal structure element, such as a floor or ceiling, ties the structural together at the level of the top plate or when the top plate itself is short enough to provide the necessary lateral strength. Let's reference this detailed illustration. Lateral bracing. The walls of a wood frame structure must provide lateral resistance to counteract the forces of wind, earthquakes, and eccentric loading. Most wood buildings are sheathed or sided with plywood or another structural sheet material that will provide the necessary lateral stability. When this is not the case, there are two good methods of bracing the building for lateral stability. These are the lead and wood brace and the curved-in metal brace. Let-in wood brace. Let-in braces should be made of structurally sound 1x4 lumber. They should be continuous from top plate to sole plate and at 45 degrees to 60 degrees from the horizontal. Take a look at this detailed illustration here on the right. Curved-in metal brace. Metal bracing set in saw kerf and nailed to each stud is not as good as lead-in wood bracing. Because of its thin profile, the metal may buckle under extreme compression. In addition, the metal framing as the lead-in wood bracing will. Let's reference this detailed illustration. Sheathing. Plywood and other panel materials may be used as structural sheathing or as finish siding. Structural sheathing panels resist lateral loads and contribute to the overall stiffness of the building, thereby eliminating the need for lead-in bracing. In earthquake or hurricane zones, or where walls are very tall or penetrated by many openings, structural sheathing may require engineering. Panels may be installed either vertically or horizontally. Vertically applied sheathing does not usually require blocking because all edges are aligned with framing members. Horizontally applied plywood sheathing is stronger because the highest quality veneers and the most plies are oriented with the strength of the plywood panel. Sheathing. This horizontal strength acts in concert with the vertical strength of the studs. Horizontal orientation is used when the stiffness of plywood is required by the backing of siding materials, such as shingles or stucco. The capacity of plywood panels to span between studs is related to the thickness and to the orientation and number of piles. The spanning capacity of composite. Sheathing. Let's reference this detailed illustration down below. Moisture and air barriers. Once the walls are framed and sheathed, they must be insulated and protected from moisture. This must be a coordinated effort involving a moisture barrier, vapor barrier, insulated and possibly an air barrier. A moisture barrier is a membrane directly under the siding that prevents any water penetrating the siding from reaching the sheathing or the framing. An effective moisture barrier stops liquid water but lets water vapor through, thereby letting the wall breathe. Moisture and air barriers. A vapor barrier is a membrane on the warm side of the wall, usually the interior, that retards the passage of water vapor from the warm inside the air into the cooler wall, where it could condense. The vapor barrier may be integral with the insulation or may be a separate item. An air barrier is a membrane that limits the infiltration of air through the wall. Either a moisture barrier or a vapor barrier may be detailed to seal the wall against air infiltration, thereby becoming an air barrier as well. Moisture and air barriers. A moisture barrier under the siding is a sensible second line of defense to prevent water from reaching the frame of the building. Many suitable products such as 15-pound felt and bitumen-impregnated paper come in 3-foot wide rolls as shown here on the right. Moisture and air barriers. It is extremely important to wrap rough openings with a moisture barrier because this is where leaks are most likely to occur and because the framing is most vulnerable at openings. This procedure is adequate for most exposed situations because all layers overlap in an order that directs water away from the structural frame of the building. Simpler methods may be employed where exposure to rain is not likely to occur. For the methods shown, many builders prefer to use thin moisture barriers that will not build up with the folds and with several layers. Let's reference this detailed illustration here on the right. Windows. Modern windows derive from the traditional wooden windows shown above. Older windows have a wooden sash that holds the glass, which is usually divided into small panes by mutton bars. This sash is hinged within a wooden frame that is fixed to an opening in the wall. At the bottom of the frame is a wood sill, sloped to shed water, and the sides and top of the frame are called jambs. These components in their terminology have been handed down to the modern window. But modern windows are better insulated and better sealed and usually need less maintenance than the traditional prototypes. Windows. Today's window is made in a factory and is usually assembled there and shipped ready to install in a rough opening. Several popular types, classified by their method of operation, include casement, double hung, sliding, hopper, awning, and fixed. Each of these types is made in wood, metal, vinyl, or a combination of two materials. Sizes and details vary with the manufacturer. Double-hung, sliding, and fixed windows are generally made in larger sizes than the hinge types. Optional trim packages are available with most. Window installation. Header. Size the header so that the loads from above do not bear on the window itself and restrict its operation. Window wrap. Wrap the framing at the rough opening with a moisture barrier to protect it from the occasional leaks that are most likely to occur around the edges of windows and doors. Shim and support. Shim the window at the sill and affix the shims to the framing so that the window is level and rests firmly on the framing. Window installation. Insulation. Place batt or spray foam insulation around the edges of the installed window to reduce both heat loss and air infiltration. Air barrier. An air barrier, if used, must be sealed to the window unit. The moisture or air barrier may be sealed to the window nailing flange at the wall's outside surface, or the vapor or air barrier may be sealed at the jamb's inside edge at the wall's inside surface. Window materials. Wood windows. Wood windows are pleasing for their warm, natural look. Along with the excellent thermal properties of wood, the aesthetic appeal of wood windows is its strongest asset. Metal windows. Metal windows are made of extruded aluminum that is screwed or welded together at mitered corners. A wide range of quality and profiles is available. Metal windows are known for their low maintenance and low cost. Higher quality units are available with thermal breaks built into the extrusion. These thermal breaks are recommended in cold climates to reduce heat loss and condensation. Window materials. Vinyl windows. Vinyl windows are made of extruded PVC. The extrusions are either screwed or heat welded at the mitered corners to make both frames and jambs. Some units are manufactured with abbreviated casings, others are made to trim to the siding without casings. Vinyl windows have not been used extensively in this country, but they look promising. Both their cost and their expected maintenance are low, while their insulative properties are relatively high. They are available in all operating types. Color is integral and is available in white, grays, and shades of brown. Windows. Backband. Backband covers the casing nail in thin flat casing and allow various widths of siding to butt against it. Cover backband nails with siding or fill nail holes. Backband may be milled in various shapes. Take a look at this detailed illustration. Windows. Drywall mold at head. Wooden drip mold can take the place of flashing drip at the head of windows and doors. It may also be used in conjunction with flashing. It is often used with shingle siding. Side casing are often covered with backband. Let's reference this detailed illustration. Windows. Brick mold casing. Traditional brick mold casing has deep profile to allow various widths of siding to butt against it. Take a look at this detailed illustration. Doors. Exterior swinging doors. Modern doors have derived from traditional prototypes. They are better insulated and better sealed, and usually require less maintenance than that of their ancestors. The material of choice for exterior doors is wood, plywood, composite, or solid wood, but insulated metal panel doors are making inroads into the market. Most exterior doors swing inward to protect them from the weather. Nearly all manufacturers sell their doors pre-hung, hinged to a jamb and with exterior casing attached. Sills and thresholds are the most variable elements in manufactured pre-hung doors. Doors. Most doors come with an extruded metal sill and integral threshold, which is installed on top of the subfloor. Wood sills must be thicker for strength, so they are installed lower than metal sills, flush with the floor framing. Let's reference this detailed illustration here on the right. Doors. Sliding doors. Sliding doors, whether they are wood or aluminum, fasten to the building more like a window than like a swinging door. Because of the weight of the sliding door remains within the plane of the wall, there is no lateral loading on the jamb of the door unit. Sliding doors are therefore supported on the sill and can be attached to the building like windows through the casing or with a nailing fin. Take a look at this detailed illustration. Doors. Interior door. Because they do not have to be sealed against the weather, interior doors are much simpler than exterior doors. Interior doors are used primarily for privacy and to control airflow. The doors themselves are typically made of wood. They are 1 3/8 inch thick and have either 6 or 4 panels, like the one shown on the right, or flush plywood veneer over a hollow core or solid core. Doors. Pocket door. Pocket doors slide on a track attached to the head jamb and are sold as a kit with the door and pocket separate and the pocket broken down for ease of transport. The pocket is assembled at the site and the head jamb, which must be set higher than 6 feet 8 inches to allow for the track, is leveled, shimmed, and attached to the frame of the building. Next, the pocket itself and the opposite jamb are shimmed and nailed. The heavier and wider the door and the better the quality of the hardware, the less likely the door is to derail. Doors. Pocket door. Pocket doors can't be made to seal as tightly as hinge doors. The walls are flimsy at the pocket, and wiring or plumbing can't be put in this section of the wall. Take a look at this detailed illustration. Doors. Garage door. Residential garage doors have evolved from swinging and sliding types to almost exclusively the overhead variety. They are manufactured primarily with a solid wood frame and plywood or particle board panels. Paneled metal, fiberglass, and vinyl doors are available in some regions. There are 2 operating types, sectional and one-piece, both which can be manual or fitted with automatic openers. Take a look at this detailed illustration. Doors. Sectional doors. Sectional doors are the most common. They are hinged horizontally, usually 4 sections, and roll up overhead. The advantages are that a sectional door is totally protected by the structure when in the open position, and it closes to the inside face of the jamb, making the design of the jamb opening somewhat flexible. Let's reference this detailed illustration here on the right. Doors. One-piece doors. One-piece doors pivot up. The door usually fits within the jamb and extends to the outside of the building when in the open position. This exposes the open door to the weather. The advantage of this type of door is the greater flexibility of design afforded by the one-piece door. Take a look at this detailed illustration. Flashing. Flashing is essential to keeping water away from the structure and the interior of a building. It is used wherever there is a horizontal or sloped penetration of the outer building skin or a juncture of dissimilar material that is likely to be exposed to the weather. Flashing provides a permanent barrier to the water and directs it to the outer surface of the building, where gravity carries the water down to the ground. Of course, the best protection against water penetration of walls is an adequate eave, but wind-driven rain may make this strategy occasionally unreliable. Flashing. Let's reference these detailed illustrations below. On the left, flashing drips. On the right, window or door head flashing. Flashing. Any horizontal member, such as a handrail, a trellis, or a joist that butts into an exterior wall, poses an inherently difficult flashing problem at the top edge of the abutting members. Where such a connection is likely to get wet, the best approach is to avoid the problem by supporting the member independently of the wall. A handrail, for example, could be supported by a column near the wall but not touching it. A trellis could be self-supported. Flashing. If a horizontal member must be connected to a wall in a location exposed to the weather, two things can be done to protect the structure of the wall. First, do not puncture the surface of the siding with the member, and do everything possible to attach the member to the surface of the siding with a minimal number of fasteners. Second, place an adequate gasket, such as 30-pound or 90-pound felt, behind the siding at the location of attachment. This will help seal nails or screws that pass through the siding to the structure of the wall. Let's reference this detailed illustration below. Horizontal wall flashing. Exterior finishes. With the exceptions of recently developed plywood, hardwood, and vinyl sidings, most of today's common exterior wall finishes have been protecting walls from the weather for hundreds of years. Applied properly, each is capable of protecting the building for as long as the finished material itself lasts. If possible, the best way to protect both the exterior finish and the building from the weather is with adequate overhangs. But even with overhangs, wind-driven rain will occasionally get the building wet. It is important, therefore, to detail exterior wall finishes carefully at all but most protected locations. Exterior finishes. Vertical edges. A vertical edge is a likely place for water to leak around the exterior wall finish into the structure of a building. A continuous moisture barrier behind the vertical joint is crucial. Caulking can help deter the moisture but will deteriorate in the ultraviolet light unless placed behind the wall finish where it will be protected. Take a look at this detailed illustration here on the right. Exterior finishes. Top edges. At the upper edges of the wall finishes, at eaves and rakes, under windows and doors, and at other horizontal breaks, direct moisture away from the top edge of the finished material to the face of the wall. Let's reference this detailed illustration. Exterior finishes. Horizontal wood siding. Horizontal wood siding is common in both historic and modern buildings. The boards cast a horizontal shadow line unique to this type of siding. Let's reference this detailed illustration. Exterior finishes. Vertical wood siding. Vertical wood siding falls into two major groups. One group, such as the tongue and groove and channel patterns shown below, has its side edges rabbeted or grooved and lies flat on the wall, one board thick. The other group, including board and batten, has square edges and uses a second layer to cover the edges of the first layer. The thicker patterns, in the second group, may require careful coordination with castings and trim. Both groups require 5/8" minimum plywood sheathing or horizontal nailing strips to strengthen the wall. Where end joints occur, siding is sealed and joined with a scarf joint or a miter joint sloped to the exterior. Exterior finishes. Let's reference this detailed illustration here. Vertical wood siding. Exterior finishes. Wood shingle siding. Shingles are popular because they can provide a durable, low-maintenance siding with a refined natural appearance. Shadow lines are primarily horizontal but are complemented with minor verticals. Material costs are relatively moderate, but installation costs may be very high. Let's reference this detailed illustration here on the right. Exterior finishes. Vinyl siding. Vinyl sidings were developed in an attempt to eliminate the maintenance required of wood sidings. Most aluminum siding manufacturers are moving to vinyl. Take a look at this detailed illustration. Exterior finishes. Stucco. Stucco is made of cement, sand, and lime. It is usually applied in 3 coats, building to a minimum thickness of 3/4 inch. Cost may be moderate in areas with high use, but high where skilled workers are few. Let's look at this detailed illustration here. Exterior finishes. Brick veneer. Brick veneer covers wood frame construction across the country. Where it is not subjected to moisture and severe freezing, it is the most durable exterior finish. Take a look at this detailed illustration here on the right. Insulation. Wall insulation is typically provided by fiberglass batts. Building codes in most climates allow 2x4 walls with 3.5 inch of insulation, R11, or 2x6 walls with 5.5 inch of insulation, R19. Let's reference this detailed illustration. Insulation. Vapor barriers. Vapor barriers are installed concurrently with wall insulation. This membrane, located on the warm side of the insulation, prevents vaporized, gaseous moisture from entering the insulated wall cavity where it can condense. Take a look at this illustration. Insulation. Faced batts. Batt insulation is often faced with a vapor barrier or with paper, which should be applied toward the warm living space. The facing material has tabs that are stapled in place between the studs. Insulation. Unfaced batts. The most effective method of insulation in stopping vapor is using unfaced batts, which are fit between the studs and to cover the studs on the inside with a continuous vapor barrier, such as 4mm polyethylene. The advantages to this system are the wall cavities get completely filled without any voids and the vapor barrier is continuous. Take a look at this illustration. Insulation. Rigid insulation. Rigid insulation can increase the thermal performance of the wall beyond the typical accepted standards. Rigid insulation is usually added to the outside of walls on top of the structure sheathing, or the sheathing may itself be rigid insulation. Insulation may also be added to the inside of the wall before the vapor barrier and interior finish. Rigid insulation should be less permeable than the vapor barrier to prevent moisture that finds its way into the wall cavity from being trapped. Take a look at this detailed illustration here on the right. Flashing. Let's take a look at these detailed illustrations below. On the left, wall insulation at foundation, and on the right, insulated headers. Wall summarizing. Framing, sheathing, moisture and air barriers, windows, doors, flashing, exterior finishes, insulation.